Lecture 4, Integumentary System. Slide 1, Title, Integumentary System, Lecture 4. Slide 2, Outline. What are the components and functions of the integumentary system? How does skin get its appearance and diseases? Slide 3, Integumentary system consists of these components. Integumentary system consists of skin and skin appendages. Your skin is actually the largest organ in your body. It is 7% of your body weight. For comparison, your brain is 2% your body weight. Interestingly, your brain and your skin develop from the same tissue layer in the embryo, the baby growing at around 8 weeks old. Your skin is quite an amazing organ. If it's sunny outside, your skin protects you from UV rays. If it's rainy outside, your skin is waterproof. It also protects you against harmful substances such as bacteria and viruses. The integumentary system also consists of skin appendages, which includes your nail, hair, and sweat and oil gland. Read Introduction to Chapter 5. Slide 4, Components of Integumentary System. 1. Skin. We'll examine the different layers of the skin. In figure 5.1, skin structure, you see a cartoon version of skin. You can see that it is layered. 2. Next, we'll look at the different skin appendages. In this image of skin, you can also see hair and your sweat and oil gland. Slide 5, Functions of Integumentary System. Why do you have skin? 1. Protection. It provides physical, chemical, and biological barriers from abrasion, microbial infection, chemicals, UV radiation, and dehydration. It also provides protection from general injury and pathogens, harmful foreign substances. Unfortunately, harmful substances can still get through, such as salts, chemical cleaners, such as paint thinner, and cleaning supplies. 2. Body temperature regulation, thermoregulation. It provides homeostatic regulation of body temperature. Remember, homeostasis is maintaining a steady, stable internal condition in your body. For example, if you get too warm, to cool off, sweat glands in your skin release sweat. If you get too cold, hair follicles raise, also giving you goosebumps, and capillaries, blood vessels, constrict to conserve heat. 3. Excretion. You excrete or get rid of substances through your skin. For example, when you sweat, you release salt, NaCl, urea, and water. 4. Production of vitamin D. Your skin performs metabolic functions, which are chemical reactions. UV rays cause modified cholesterol molecules to be converted into vitamin D. This aids absorption of calcium across the digestive tract. This is why you often see vitamin D and calcium together in supplements in food and drinks. 5. Sensory reception. Your skin senses pain, temperature, touch, and pressure. Read section 5.1, the skin and subcutaneous tissue, the introduction. Slide 6. Skin has 2 layers. Study figure 5.1, skin structure, and 5.2, growth structure of skin and underlying tissue. Epidermis. This is your first outer layer of skin and can be further subdivided into 4 to 5 layers of epithelial tissue. Epi means on top or on the outside. So the epidermis is the layer of skin that you can see and touch. Dermis. This is your second layer of skin that is deep or below to the dermis. It contains 2 to 3 layers of connective tissue. Hypodermis is below your actual skin. What does hypo mean? Below. Think the opposite of hyper, which is too much. Think of a hyperactive child, which has too much energy or activity. So this layer is called hypodermis because it is below the dermis. It is also called subcutaneous layer. Sub also means below, and cutaneous means skin. The hypodermis is technically not skin, but rather it is attached below the skin and to other underlying organs. Slide 8, epidermis cell types. Now we are looking at 4 types of cells doing these similar functions in the epidermis. Study figure 5.3, epidermal cells and layers of the epidermis. Read section 5.1a, epidermis. 1. Keratinocytes. This is the major cell type of the epidermis. Note, when you see the term cytes, that refers to a mature adult cell. They produce keratin for strength and protection. This is why they are called keratinocytes. They are mature cells that make keratin. As the cells get pushed more apically towards the surface, they produce more keratin. The surface cells are actually dead and are sloughed or brushed off, which is why they look different. 2. Melanocytes. They are found in the deepest layer and produce a brown pigment called melanin, which is taken up by surrounding keratinocytes. This is why they are called melanocytes. They are mature cells that produce melanin. 3. Dendritic cell. These help with the immune system for protection. They are phagocytes that eat foreign substances. Tactile Merkel cell. These are located in the deepest layers and help with touch sensation. They come into contact with sensory nerve endings, so they help signal to the brain that your skin has been touched. Slide 9, epidermis layers. Overall, the epidermis is only about 1.5 to 1.6 millimeters thick. Where do you think your skin is the thickest? Thinnest? Your thickest skin is in the soles or bottom of your feet, palms of your hands, and lips. Why? These are areas that come into contact with items a lot, so they need extra protection. Your soles touch the ground. You use your hands to grasp objects often. Your lips touch food. Your thinnest skin is your eyelids, where you still need light sensation even if your eyelids are closed. The number of distinct layers of the epidermis determines whether the skin is considered thin with 4 layers or thick with 5 layers. Thin skin is hairy and is found on all parts of the body except palms, soles, and lips. Thick skin is found where exposure to friction is the greatest. Palms of the hands, including fingertips, soles of feet, and lips. It has extra layer, and the other 4 layers are thicker as well. Study figure 5.4, thick skin with emphasis on stratum lucidum. Slide 10, epidermal layers. All these layers make skin tough and protected. Let's examine the 5 layers. We'll start with the deepest layer. But before we start, notice that each layer is called stratum. Stratum means layer. Study again figure 5.3, epidermal cells and layers of epidermis. Review sections 5.1a, epidermis. 1. Stratum basal or stratum basale. This is the deepest epidermal layer firmly attached to the dermis below. You'll notice that this layer is somewhat wavy. Keep that in mind as we will talk about this layer. The cells are mostly keratinocytes. Then there are scattered melanocytes, tactile cells, and dendritic cells. Most importantly, there is a single row of stem cells that go through mitosis. From lecture 2, what are stem cells? Remember, stem cells can mature into a variety of cells. In this case, the cells often mature into keratinocytes. Recall from lecture 2, what is the significance of mitosis? These cells can divide. This will be very important. 2, stratum spinosum. This layer is known as the spiny layer. It is made up of connected keratinocytes that are connected somewhat like a spider web. These spines or webs connecting keratinoid cells give each other lots of strength. It also contains some dendritic cells. Remember what they are important for: immunity. So you don't want any harmful substances entering too deep into the skin. 3, stratum granulosum. This is 3 to 5 layers of keratinocytes and is important because these cells now start making keratin for this layer and the more superficial layers. We call that keratin as the protective protein and helps make your skin waterproof. At the same time, these cells have stopped dividing and are undergoing apoptosis, programmed cell death. It is a transitional layer. Cells flatten out, nuclei and organelles begin to disintegrate. 4, stratum lucidium. This layer is only in thick skin. It is the added 5th layer. It appears thin and translucent, clear. It contains a few layers of clear, dead keratinocytes packed with keratin, offering extra protection and thickness. It is very obvious when you have calluses on your feet or hands. That is a thickened stratum lucidium layer. 5, stratum corneum. This layer is the most superficial layer and is 20 to 30 layers of flattened, dead keratinocytes. The interior of cells is mostly keratin and nothing else. This layer is continuously shed and replaced. Multiple layers of dead cells help protect deeper layers from injury and microbial invasion. As you can see, all layers have keratin, which offers strength and ultimately protect. Now, let's talk about the movement of these layers. They are not stationary. Think of it like a conveyor belt at a grocery store checkout. The start of the conveyor belt would be the deepest stratum basale layer, and the end of the belt would be the most superficial stratum corneum layer. The melanocytes, dendritic cells, and tactile cells stay put. You don't move up the conveyor belt. The keratinocytes start at the bottom and move to the top, though. As the cells move from one layer to the next, they accumulate more keratin and become more protective. It takes about 6 to 8 weeks to make it to the top. You are actually shedding thousands of cells each hour as you just sit or walk around. That is why it's so important for stratum basale to go through mitosis so you can replace those lost skin cells. At this rate, you would shed your entire skin in about 2 to 3 months. You should have a whole new outer skin by the end of the semester. Slide 11. Skin has 2 layers. Now let's focus on the second layer, the dermis. Slide 12, dermis. The dermis consists of strong, flexible connective tissue. It is attached to the epithelium via the basement membrane. We looked at this in our lab when we labeled all of our epithelial tissues with the basement membrane or basal surface. Read section 5.1b dermis and study figure 5.1 and 5.4 again. There are 2 layers of regions of connective tissue. First, papillary dermis. This is the superficial of the 2 layers. It makes up about 20% of the thickness of the dermis and is made of areolar connective tissue. Remember that from lecture 3 and drawing it in lab? Importantly, in this layer are papillae, which give it its name. Papillae are the wavy ridges that make up your fingerprints. Remember how we said that stratum basale, the deepest layer of the epidermis, was wavy? That's because it comes in contact with this wavy papillary dermis layer. This causes protrusions upward that make your fingerprints. The pattern of the waves is different in each individual, giving everyone unique fingerprints. Second, reticular layer. The layer is the deeper of the two dermis layers. It makes up about 80% of the thickness of dermis and is dense, irregular connective tissue. Remember looking at that in lab 3? It has collagen and elastic fibers that are oriented in all directions that provide strength and resiliency. This is important. For example, try to move your skin around. Can you move and stretch it in all directions? Or does it only move in one direction? You should notice that you can move your skin in any direction. That is because these collagen and elastic fibers are positioned in irregular patterns in all directions. Let's look at some applications of the dermis. 1, stretch marks. What do stretch marks look like? They tend to be white lines. When do you get stretch marks? An example is when you are pregnant and gaining weight rapidly, or in other words, stretching the skin within a relatively short amount of time. What is happening? You are tearing the dermis, specifically the collagen and elastic fibers. It's like breaking an elastic rubber band. When the fibers initially break, you'll see red-blue, which is the blood vessels also breaking. Then it is replaced by white, which is the scar tissue. Unfortunately, collagen fibers don't regenerate well, and therefore the white scar tissue tends to last. Similar to stretch marks are wrinkles. These occur when you start to lose fibers, especially the collagen ones. This causes the skin to sag and become wrinkly. 2, cleavage lines. Even though your dermis tissue is irregular in pattern, there are large overall directions in which the fibers go, and these form cleavage lines body-wide. These are useful in the clinic because if an incision needs to be made in the skin, it is best to go parallel to the direction of the natural cleavage line so you don't cut through as many fibers. This will lead to better healing of the skin with less scars, for example, from surgery. See figure 5.5a, cleavage line. Slide 13, dermis, other components. Let's look at other organs that you find in the dermis layer. Oil and sweat glands. These glands are the twirly structure. The oil gland you find right next to the hair follicle. Hair follicles, which start in the dermis and then give rise to your hair. Blood vessels, which are for nourishment of your skin. Did you remember seeing blood vessels in the epidermis? Does epithelial tissue have blood vessels? No. Why not? If you have blood vessels on the surface, then if you just got a tiny scratch or touch your skin, you would start bleeding. You don't want that. So if you cut your finger and it bleeds, you know you have reached the dermis. What has the cut gone through already? The epidermis with its 4 or 5 epithelial layers and the basement membrane. Nerve cells for sensation. The tactile cells are in the epidermis, but the actual nerve cells with endings are in the dermis. Slide 14, hypodermis. Deep to the skin is the hypodermis or subcutaneous layer. This is below the epidermis and dermis. Below the hypodermis is the fascia, which is connective tissue, dense, regular, surrounding muscle. That is why the hypodermis can also be referred to as the superficial fascia, since it's above the fascia. The hypodermis is made up of mostly adipose tissue with fat cells. Females on average have about a 7% thicker hypodermis layer. Fat helps cushion and insulate, which are both important functions of skin. The cushion helps with overall protection and absorbs shock from a fall. Think about why babies have so much baby fat. They are falling all the time and need that extra cushion. The insulation helps maintain body heat and body temperature. The hypodermis also consists of other loose connective tissue, areolar, with collagen and elastic fibers similar to the dermis. It helps anchor the skin to other underlying structures like muscle, but allows for movement so that skin can move and not disrupt the muscle or other organs underneath. Read section 5.1c, subcutaneous tissue. Slide 15, discuss, think, and write exercise. This will help with your lab 4 on integument to fill out table 1. For identifying tissue types, think about what types of tissues, recall from lecture 3, there are. For example, is it epithelial or connective tissue? If it's epithelial, then what type? Simple or stratified? Squamous, cuboidal, or columnar? If it's connective tissue, then what type? Areolar, adipose, dense regular, irregular, cartilage, bone, blood? This will also help you organize the basic layers of skin that we've discussed so far. Slide 16, skin color is determined by pigments. What is a pigment? Any substance that causes a color change. There are 3 main pigments that contribute to skin color. First, melanin gives skin the brownish color. This is a protein from melanocytes, which we saw in the deep layers of the epidermis. Different people naturally produce different amounts of melanin. The more melanin you produce, the darker color your skin is, which is why naturally some people have darker skin. That's based on genetics. Sometimes you can get local accumulation of melanin, which can lead to freckles, where you have more melanin. Tanning also increases melanin. This happens because melanin actually helps block harmful UV rays. So if you're exposed to the sun, your body thinks, hey, I'm being exposed to harmful UV rays. I better produce more melanin to protect myself. And therefore, your skin gets darker or a tan. So a tan is actually a protection mechanism. But then, of course, too much exposure to sun can be damaging. It can damage your elastic fibers, causing wrinkles, and ultimately it damages DNA, which can lead to skin cancer. Second, carotene. Carotene is a yellow to orange pigment found in orange vegetables like carrots, hence the name. It also accumulates in the stratum corneum layer and fatty tissues of hypodermis to give skin an orange color. Third, hemoglobin is located in red blood cells, and when bound to oxygen, hemoglobin is bright red. Recall that there are blood vessels in your dermis and hypodermis. When the blood supply is reduced, the skin becomes relatively pale. This might happen when it's cold outside. When blood flow to the skin increases, like when it's hot outside or you're exercising, then your skin appears more pink. Cyanosis is when oxygen levels in tissue decrease due to reduction in circulatory supply. And so you lose the red color from hemoglobin and your skin becomes bluish. Cyan is a shade of blue. Read section 5.1d, skin color. Application. Think about tattoos. This is putting color into your skin. Which layer would you deposit or put the color for a tattoo? Epidermis? What do we know about the epidermis? How long does it take to replace the epidermis? Recall, it only takes about 6 to 8 weeks for the epidermis to be replaced. If you placed your tattoo in the epidermis, how long would it last for? Should the tattoo pigment be placed in the dermis? Let's think about that process. Do you bleed? Probably. If you bleed, what layer must you be in? Do you feel pain? Probably. Think about which layer the nerve sensation cells for pain are in, not just the tactile cells for touch. So, which layer and why? Read a closer look, tattoos, in section 5.1b. Summary. Think back to our original outline and question. We've now addressed both of these. What are the components and functions of the integumentary system? The integumentary system serves several functions. It is 2 layers, epidermis and dermis, with the hypodermis below. Each has different tissue types and components. How does skin get its appearance and disease? Skin color is a result of 3 pigments. Slide 18. Integumentary system also includes skin appendages. All of these structures derive or come from the same epidermis tissue. Read 5.2 Appendages of the Skin, the introduction. Slide 19, nails. Let's look at the structure of nails. Feel your nails. How do they feel? Probably hard. The hardness is just hard keratin. This is the same keratin we find in skin, except the skin keratin is softer. In fact, nails are just a scale-like, harder modification of the epidermis. The nails are located on the distal, remember further away, part of your finger or toe. Think about how often you have to cut your nails. They definitely grow. And that's because there is a matrix portion of the nail that goes through mitosis. Recall that mitosis is cell division, so this is where your nail grows from. If you look closely at the nail, the part that you would cut off is the free ridge, free edge. Then there is the body. You might see a little half crescent moon called the lanule. Then the cuticle covers the proximal part of your nail. Protected under here is where you find the matrix for mitosis. Read 5.2a, nails, and study figure 5.6, structure of nail. Slide 20, hair. Let's look at the structure of hair. Hair is also called pili. It is composed of columns of dead keratinized cells. Hair is everywhere, so widely distributed. It is on the surface, the entire surface, except palms, soles, lips, and nipple. Hair functions to protect. For example, hair guards the scalp against physical trauma, heat loss, and sunlight. It also helps you detect touch. Something can brush your hair and not touch your skin, and you can feel it, such as alerting the body to the presence of insects. Read 5.2b, hair and hair follicles, with the section on hair, and study figure 5.7, structure of hair and a hair follicle. Slide 21, hair follicle. Inside the hair follicle is the root, which penetrates into the dermis. The shaft is the superficial portion of hair, which is what you can see on the surface. The deep end of the follicle is expanded, forming a hair bulb, which contains matrix. which receives nutrients from blood vessels, which allows mitosis to occur, like the nail matrix. So this is where your hair is produced and grows. If you pull your hair out and see the little white tip at the end, that is the hair bulb. If the hair bulb comes out, then it will take longer for your hair to grow back because it has to reform the bulb with the matrix. Why do some people have wavy hair? The hair follicle is not straight. Why do some people go bald? The hair matrix stops going through mitosis. This is common as people age. Male baldness is from a gene that switches on sometime in adulthood that causes the hair follicle to respond differently to testosterone androgen. The erector pili is a smooth muscle. When it contracts, it pulls up the hair, almost like pulling up a sail on a boat, which causes the hair to stand upright. This happens, for example, when it is cold and the hair in your arms stand up. Read 5.2b, hair and hair follicle, with the sections on hair follicles and hair thinning and baldness. Study figure 5.7, structure of a hair and hair follicle. Slide 22, glands. Recall that glands are epithelial tissues, since epithelial tissues are either on the surface or form glands. Oil and sweat glands are multicellular with ducts. Slide 23, sebaceous oil gland. You find sebaceous glands, also known as oil glands, everywhere on your body except the palms and soles. Think about how oil feels. It's pretty slippery. Now, think, why would you not want oil on your palms or your soles? Imagine trying to hold something with oily hands. Oil glands secrete sebum, which is a protein in oil. Oil glands secrete into hair follicles. So when you look at the image of a hair follicle, you'll often find the oil gland right next to it with the duct leading into the follicle. It can also lead into a skin pore. This helps keep hair moist and provides a protective sealing layer on the skin to keep it moist also. Sebum also helps inhibit bacteria. This is why if you don't wash your hair for a while, your hair gets oily. Application. Acne can arise when oil glands are too active and secrete too much sebum into the skin pores. This clogs the pores, causing bacterial growth instead of preventing it, and leads to pimples, whiteheads, and blackheads. Read 5.2c, sebaceous gland, and clinical application, acne. Study figure 5.8, skin gland. Slide 24, sweat gland. There are two main types of sweat, also called sudoriferous gland. Acrine, also called merocrine. These are more numerous and widely distributed. You have a high number of acrine glands in palms, soles, and forehead. Think about where you sweat a lot. These glands produce your standard true sweat, or perspiration, which is 99% water. It also includes salt. If you ever tasted your sweat, it tastes salty. It also includes electrolytes, organic nutrients, urea, uric acid, amino acids, glucose, and other waste products. The major function is to cool the surface of the skin to reduce temperature, which is called thermoregulation. 2, apocrine. These glands are focused in the armpits, around the nipple, and groin. They secrete same basic components as true sweat, plus some organic components such as fatty substances and protein. When these organic components are decomposed by bacteria, the sweat can become odorous, which is why this sweat can smell. When do these apocrine glands become active? Another way to ask this question is, when does someone start needing deodorant? Often during puberty. It is hypothesized that these odor apocrine glands are to attract mates sexually. You may think that's odd, but studies have shown that females prefer the shirt of a male that has been sweated in rather than a clean one. and that usually each female prefers a different male scent. Read 5.2d, sweat gland, and study figure 5.8, skin gland. Slide 25, burns. What causes a burn? It can be exposure of skin to heat, radiation, electrical shock, or strong chemical agents, such as in chem lab, like an acid, which denatures cells, protein, and results in cell death. One major effect could be body fluid loss through the burn site. Also, by damaging the skin, you lose your protective barrier. So bacteria and other harmful agents can enter the body and cause sepsis, which is a body systemic wide infection, which can be deadly. There are different degrees of burn and severity. First degree, only the epidermis, first layer, is damaged. Skin reddened due to inflammation of the tissue that is painful, but no blisters form. A mild sunburn is included in this category. Second degree, epidermis and upper region of dermis is damaged. You have blistering, pain, and swelling, which is edema. Blisters may rupture, increasing the likelihood of infection. Healing takes 1 to 4 weeks, but usually doesn't require skin grafting, replacing the skin, and scar tissue may or may not form. Note, a blister is a space between the epidermis and dermis layers by fluid-filled pocket. Blood blisters is when blood vessels from the dermis break into the blister. Third degree, entire thickness of skin is burned, including the hypodermis. It appears gray, white, cherry red, or blackened. Nerve endings are destroyed, so the burn area is actually not as painful. Skin grafting is almost always required. Read section 5.3, disorders of the integumentary system, introduction, and 5.3a, burns. Study figure 5.9, burns. Note, we will cover clinical applications of burns in lab. For further clarification, watch burns, 4 minutes, animation on APR. Slide 26, skin cancer. Like all cancers, skin cancer is caused by uncontrolled cell growth. Risk for skin cancer increased with exposure to UV rays and lack of melanin. Someone with naturally lighter color skin has less melanin and is not as protected from the UV rays. Albino, people that lack skin pigments, can't and are especially susceptible to skin cancer. Sunburns are a warning sign that you have been exposed to harmful UV rays. The DNA in the skin cells get damaged, which causes those cells to divide too quickly. To reduce the risk of skin cancer, you want to avoid the intense UV rays, so avoid the high intensity sunlight around 10 to 2 p.m. and use sunscreen, sunblock, that blocks the UV rays. Some common types of skin cancer are basal cell carcinoma. Think about where this occurs. Stratum basale in the epidermis, which is where mitosis occurs, so this goes out of control. Squamous cell carcinoma is in the keratinocytes of stratum granulosum of the epidermis. Melanoma is in the melanocytes in the deep layers of the epidermis. Recall that melanocytes produce the brown pigment melanin, also found in mold. That is why fast mold growth, which would be melanocytes going through rapid cell division, can be a sign of melanoma. Read section 5.3b, skin cancer, and examine figure 5.10, photographs of skin cancers. Slide 27, summary. Think back to our original outline and question. We've now addressed both of these even further. What are components and functions of the integumentary system? The integumentary system includes skin appendages, which are epithelial tissue, nails, hair follicles, sebaceous glands, and sweat glands. Each have unique structures that fit their function. How does skin get its appearance and diseases? Burns and skin cancer are harmful alterations of the skin integument. For optional review videos, Khan Academy has a good series on the integumentary system. Functions of the integumentary system: meet the skin, epidermis, what is skin, dermis and hypodermis, including burns, what lies beneath the epidermis, nailed and hair, where do nailed and hair come from, sebaceous and sweat glands, what is in sweat, holocrine, apocrine, merocrine gland.